Hello students! Welcome back to another geometry lesson. Thank you for watching. Flipgrid of the day, up there at that link. Go do it, it's good fun. Today's YouTube lesson you have already found. And now, write this problem in your notes. Pause the video and ask yourself, where is this function, this graph right here, where is this equal to 0? Can you tell from the graph? Can you tell where this thing is equal to 0 by just looking at the graph? Yes. The answer is yes. You can. So where? Where? That is what today's lesson is about. We'll be answering that question today. The quick answer is wherever the graph crosses the x-axis. That's the quick answer. But we're going to jump more into that as we go through the lesson today. Speaking of the lesson for today, here is what it is about. We begin chapter 9 today. We are skipping 9.1 for the sake of time, and we are moving on to 9.2. Solving quadratic equations by graphing. How can you use a graph to solve a quadratic equation in one variable? When they say in one variable, that just means it's x squared plus bx plus c. It's x, not x squared plus by plus c. No, that's two variables, and this is one variable. Okay, all right. I know what solutions to quadratic equations look like. That is our learning target, and our success criteria is I can find solutions of quadratic equations by graphing. Okay, so we need to know what they look like. We need to be able to find them. We need to know what they look like, and we need to know how to find them. Those are our goals for today. Important information. Don't write this down. Just keep it in your brain. So, solving a quadratic equation. Step 1, write the equation in standard form. That's what we call standard form, the ax squared plus bx plus c. That is standard. Graph the related function. And step 3, find the x-intercept. The solutions are the x-intercepts of the graph. Just like I told you in the entry task, if we have a graph like this, the x-intercepts are the solutions, because, remember, this is where, this is where y equals 0. The y-axis is where x equals 0, and the x-axis is where y equals 0, right? Because y goes up and down. Y goes up and down, so if I'm down, I'm negative. If I'm up, I'm positive. But if I'm on the x-axis, I'm exactly 0. So what this equation says is, when is this function equal to 0? Where is y equal to 0? Well, y is equal to 0 on the x-axis. So wherever the graph hits the x-axis, those are our solutions. We call the solutions, we call them roots of the equation. Yeah, so solutions, roots, x-intercepts, all the same thing. Okay, so example 1, solving a quadratic. 2 real solutions. So that there are different scenarios, different cases of things that can happen when solving an equation that looks like this. There can be 2 real solutions, there can be 1 real solution, or there can be no real solution. So I'm going to take you through each of those cases. So, first, solve x squared plus 2x equals 3 by graphing. Well, remember, step 1 was to write it in standard form. I want this thing equal to 0. So in order to get it equal to 0, I need to subtract 3 from both sides, and I'll get x squared plus 2x minus 3 equals 0. Step 2 is to graph the related function. So step 2 is to graph y equals x squared plus 2x minus 3. Now, if we were in school, this might be a little bit different, but for the sake of time, since we are at home and we don't have a lot of time to do lessons, we're going to do this differently. When I say graph yx squared plus 2x minus 3, we are going to do this using, there we go. We're going to do this using Desmos. So all I have done, I have just typed in desmos.com up here, and up pops this. If you click this button where it says Start Graphing, it's going to take you to an online graphing calculator. Now, normally we don't use graphing calculators in Algebra 1. Advanced Algebra is another story. But we're going to do it this time because we're running out of time. So for the sake of simplicity, we're going to graph x squared, oh my, x squared. And to do that square, I just hit Shift 6 and do the little caret. X squared plus 2x minus 3. Ta-da! And now we have our graph. So we have graphed it. Awesome. What was step 3? If we go back here, step 3 was to find the x-intercept. So, step 3 with, that's a 3, x-intercept are something and something, because there are 2, right? So if I switch back to our graph, see here there's 2 x-intercepts, there's one here and there's one here, and if I hover over them, it shows me exactly what they are. -3 and 1. -3 and 1. So now, I'll go back here. X-intercepts are -3. -3 and 1. So, x -3 or x equals 1. Now, do you have to use the Desmos calculator, or can you use the graph right here that they gave you? Can you use your own graph paper? That is a very good question. The thing is, if we do this, if we graph this function how we've normally been graphing these functions, we find the vertex, and we do the axis of symmetry, and we find the y-intercept, and then we connect the dots. Cool, I've connected the dots. That doesn't land perfectly on the x-axis, like, because this isn't a perfect graph. Because we're just using 3 points to approximate the graph, it doesn't do a great job of giving you exact answers up here. So, that's why we are not using these. This is why we're using Desmos instead. So, use Desmos, makes your life easier. If you want to use the graph, just make sure you get really precise. Okay, and they didn't put it up here. But there is an optional, put it down here. There is an optional, I'm in the way, you can't see it. Optional step 4, which is to check your answer. It's always a good idea to ask the question in math class, can I check my answer and how? Because when you're doing math in the real world, say you're building a bridge with a team of physicists or something, good idea to check your answer before you let people drive on that thing, because you could kill people. So, checking your answer is always a good idea. So the way to check is we take this, here, let's get a different color in. We take our equation and we're gonna plug in these numbers. So x squared plus 2x minus 3, that should equal 0. Now what if I make x equal to -3? So -3 squared plus 2 times -3, oops, minus -3 equals 0. Negative 3 squared 9. 6 minus 3 is 0. And oh, would you look at that? 9 minus 9 is 0. Yes, indeed. So this one is good. And we can do the same thing with 1. We are running out of space. Let's do it up here. 1 squared plus 2 times 1 minus 3 equals 0. So 1 plus 2 minus 3 equals 0. Oh, look at that. 3 minus 3 equals 0. Yep. That definitely, indeed, works. So, yay. Optional step 4. Good idea. Good idea to do step 4. And we can check our answers. Negative 3 and 1. And look at that. They checked just like us. Good, 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 good. Okay. Example 2. Solving a quadratic, 1 real solution. So, you can already get an idea of what this graph is going to look like by thinking about what did the graph of our last one look like. This is what the graph of this one looked like, and it had 2 real solutions because it crosses the x-axis twice. So, what might the graph of, if it has 1 real solution, what might the graph look like? Pause the video and think about it if you want to. Okay, and then unpause it to start example 2 with me. So, step 1, standard form. So, gotta get it equal to 0, plus 16 on both sides. X squared minus 8x plus 16 equals 0. Beautiful. Step 2, graph y equals this. X squared minus 8x plus 16. Alright, and we are going to come back to Desmos. Y equals, whoa, hey, type in here. Y equals x squared minus 8x plus 16. Ta-da! Oh my goodness, why can't you see it? Oops, was typing it in this whole... Okay, y equals x squared minus 8x plus 16. So now here is our graph. And yeah, if you click and drag, you can move it around. So here's my x-axis, the bold line. And notice the only place that this touches the x-axis, there's only one place. 4, 0. Only one, there isn't 2. So, if we come back to our problem, remember, when your graph crosses in 2 places, we have 2 solutions. If your graph only lands on the x-axis once, then you only have 1 solution. So step 3 is find the x-intercept. Intercepts, because sometimes there aren't always, so sometimes it's intercepts and sometimes it's just 1 intercept. So the x-intercept in our case is 4. So that means x equals 4. Only 4, not x equals 4 or x equals 5. Nope, just x equals 4. And let's check to our optional step 4. So, x squared, remember we're going to take this and we're going to put it in here. So, 4 squared minus 8 times 4 plus 16. And this is 16 minus, 32. Minus 32 is negative 16. And remember, we wanted all of this to be equal to 0. And it is true. 0 equals 0. Awesome. So x equals 4 is correct. Let's check if we were right. Yeah, look at that. The only x-intercept is at the vertex. Negative 4, 0. So the solution is x equals 4. Yay! We were right. Look at that. We can even turn our parabola into a smiley face. Okay, alright. Example 3. We're going to solve a quadratic now, but it's going to have no real solution. So what do you think it's going to look like? This was 2 solutions, and then we saw this is 1 solution. What do you think no solutions is going to look like? Get it in your mind. Pause the video and think about it if you want to. And now, step 1 is to get this in standard form. So if we move the x over to this side, we'll get 0 equals x plus 2x plus 4. And remember that this is positive, this 2x is positive, so that's why we end up getting the plus 2x right here. Okay, and also remember that just because this is equals 0, we can swap that equals 0 and put it on the other side. Doesn't matter if we have it over here or if we have it over there. Does not matter. As long as it is equal to 0, that's what matters. So, awesome. Step 2 is to graph, you guessed it, y equals x squared plus 2x plus 4. We're going to use Desmos, not this. So let's switch on over to Desmos, and let's type in what we want. We have y equals x squared plus 2x plus 4. And there we go. Okay. So remember that step 3 was to find the... Hey, stop that. Step 3 was to find the x-intercepts. So, let's look for them. Here's the x-axis, and, oh! It doesn't have any x-intercepts. What? Oh my goodness. Maybe that's why it says no real solutions. Because step 3 is to find the x-intercepts, and there are none. There are no x-intercepts. So x equals nothing. So instead of writing x equals, we write no real solution. No real solution. And we have to write real. You do need to write real because there are complex solutions. Yes, there are always complex solutions. And that is something you'll learn about in advanced algebra. But for now, all you need to do is write down no real solution. Let's check and make sure that we were right. They do it in a little bit different of a way, but look at that. This does not cross the x-axis, so because these are completely separate, no real solutions. Okay. Alrighty. So, no need to write this down, but it is important information. A quadratic equation has 2 real solutions when the graph has 2 x-intercepts. 2 x-intercepts. 1 real solution when it has 1 x-intercept. And no real solution when it has no x-intercepts. So the number of solutions is the same as the number of x-intercepts. And this is true for any graph. If we go back to Desmos and I type in y equals x cubed plus 2x plus 4, there's only 1 real solution because there's only 1 x-intercept. If we make this a little more crazy like that, now there's 1, 2, 3 real solutions because it crosses the x-axis 1, 2, 3 times. We could make this, let's make it even crazier just for fun. Look at that. Look at that. Now there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh my gosh, there's just hundreds and millions of them. Yes. Yes, there are. So the number of solutions is the same as the number of x-intercepts. Back to our slides. And again, the graphs. Let's draw pictures of what the graphs look like for this. So, 2 solutions. The graph looked like this. And we'll even put colors. They looked like this. 1 real solution. So 1, oops, use the numbers. One solution looked like this, where the vertex was on the x-axis, and no solutions, no real solutions, excuse me, looked like this, where nothing, no real solutions. Okay. So, that is all I have for you today. If you have questions, remember office hours. Office hours. Every Tuesday through Friday, 12:30 to 3. Every day, every Tuesday through Friday, unless otherwise posted, unless a meeting comes up or something like that. Or the senior cap and gown giveaway, which was super fun. But yes, please ask questions. Join the Google Meet link. If you don't know where the Google Meet link is, go to our Google Classroom and look up. Look up at the top. I'm not going to share it on a YouTube video because I don't want some weirdo finding the link and doing things with it. So, yeah, please ask me questions if you have them. Your homework is only 6 questions. In 4 of them, I already graphed them for you. The other 2, you need to graph them. But yeah, solve the equation. So x equals what? And are there 2 of them? X equals this or x equals this? Is there only one? Or are there no real solutions? So these are the options for what your answer looks like. Okay, and your lunch for today. Don't wait. The time will never be just right. And that is by Napoleon Hill. So of course, I want to preface this by saying this does not apply to everything. Don't wait to do drugs. No, it does not apply to that. Never do drugs, ever. Always wait to do drugs. So the places that this does apply are for things that are going to make you a better person. Things that you want to do, but maybe you're a little hesitant about doing it. Don't wait to work hard in school. Don't wait until June and then go, oh crap, I better get my grades up. No, don't wait. Just keep good grades all year so that you're not super stressed out at the end. Don't wait to think about college. You might think like, oh, I'm not smart enough. Oh, I don't have enough money. Like, no. Don't let any of that stop you. Don't wait to think about going to college and getting a better education and bettering your life. Yeah, don't wait to start that hobby that you've been thinking of. Like, maybe you want to get better at drawing. Don't wait. Draw now. Why wait? Yeah, this applies to anything. Any skill that you want to learn, learning a new language, taking pictures, photography, whatever it is. Don't wait, because the time will never be just. So, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thank you for watching. Bye.